Hello everyone. In this tutorial, let's look at how to control volume using Python. Now, like in any other program, let's import all the required libraries. In this, we have CV2, that is the name is OpenCV, stands for Open Source Computer Vision Library, which is an open source library that includes several hundreds of computer vision algorithms. So let's import that first. Then let's import MediaPipe library, which is a library that offers a cross-platform customizable ML solutions that mainly help in facial recognition techniques. So let me import that as import MediaPipe as MP. Now we have math library, which provides access to mathematical functions that are defined by the C standards. There is a C language standards. Now, from math library, we need only the hypotenuse function. So let's do that. From math, import hypot. Now we are done importing hypot function. Now let us import ctypes function in ctypes library, and the required functions from it are cast and pointer. In C, when there are instances of incompatible data types, we can cast one type into another type. In the same way, cast function helps in casting one type into another type in Python. So, and the pointer of function takes as a parameter the type of pointer you wish to create, that is an integer pointer. So let's import that first. From C types, import cast comma pointer. Now we are done with importing the C types library. We have com types library, that is a lightweight Python com package, and from com types we need only the clsctx function. From com types, from com types, import clsctx underscore all. Now we are done importing the com types. We have the Python core audio Windows library that works both for Python 2 and Python 3. From that, we import audio utilities, which is a class that contains get speakers off function, get microphone off function, and etc. that we use further in the tutorial. And also I endpoint volume that contains all the com types for the function. Let's import from dot import. As I said, we need only audio utilities and iAudio endpoint volume, and be careful with the spellings. Audio utilities, comma iAudio endpoint volume. Yeah, now we have imported the required functions from this. Also, the last library, which is a well-known library, that is NumPy. NumPy is a fundamental package for scientific computing in Python. It's a Python library that provides a multi-dimensional array object. So let's do that. Import NumPy as NP. Now we are done with importing all the required libraries for the tutorial. Let us start with the functionality of the program. The very first thing we need is we need to check whether there is an availability of camera or not in order to further start with the application. From CV2, I'll call video capture function and I'll set it to 0. What this does is this checks for the availability of camera. Now, if this is true, the further functionality works. So as we have checked for the camera, next we shall declare a variable for detecting fingers of the hands. Let that be mp hands equal to mp.solutions.hands. That is, what this does is that it checks for the fingers. It detects the fingers. Let me comment that for you. Detects. Now we have detected the fingers. Next we have to detect whether there is a hand present or not. Not just the fingers, we need to completely read the hand. So let's detect the initialize and configure the hands now. Let me declare hands as a variable. In hands, I'll give mp hands dot hands of function. That's why I already said that MediaPipe provides solutions for all these ML techniques. It's a very useful library. If you want, you can go check the documentation too. Now, what this does is it completes the initialization and configuration of the hands and fingers both. Now we are done with the declaring of all the required variables for detecting fingers and hands of the person that is using. Let us initiate the solutions.utils function. This is done by, let's declare a variable mpdraw, wherein mpdraw is equal to mp.solutions dot draw il underscore utils is a function that we need here. So draw underscore utils. Now we are done declaring a variable for the solutions.utils function. On defining and detecting all the fingers and hand, we shall access the speakers of the system. For this, we have imported audio utilities function as I have said above. I'll declare a variable name devices, wherein devices contains audio utilities dot get speakers of function. Now I have declared devices variable wherein we activate or we access the speakers of the system that we are working with. Now the audio endpoint interface represents the volume controls on the audio stream, or the form of audio endpoint device that we are using. So let me declare a variable called interface equal to devices dot activate. That is, devices is the variable that we stored audio utilities dot get speaker function. Devices dot activate off. In this activate off function, we call I audio endpoint volume function. Along with this, we've also discussed about CLS-CTX that declares how to use the COM types. Score all, and let's set this to none. We are done creating the interface variable. Now let us set the volume level of all the channels to same volume. That is, whatever interfaces we are using, they'll all be set to the same value. That can be done by volume is equal to cast of interface. We have declared interface variable, right? So interface comma pointer function is being called here. So in pointer we call the I audio endpoint function. Yeah, so now we are done with setting the volumes to same channel or same volume. Now let us declare the variables that define the volumes bar height and volume percentage. I mean, we are also depicting how much of the change or variation there is in the volume bar. So let me set that to vol bar as a variable, and I'll set that to 400. So next I'll also display the volume percentage. I'll set that to 0 initially. So now these are set to 0 and 400. Yeah. Now the code above finds the volume range between the minimum and maximum volumes. Now we place this outside the loop because we need to find the volume range only once. Let me declare vol min and vol max, and I'll set these to be volume dot get volume of get volume range of, that is 2. So what this does is the minimum and maximum volume ranges can be found out through these volmin and volmax variables. Let us check the conditions that are required. While true, while the condition is true, we declare the variables named success image, which captures the image that we have worked with. So let's declare them here. Img, where I'll read the capture variable when there is a camera. Read off. If the camera works, it captures the image. That's what this does. Then on capturing the image, we need to convert the image into the corresponding RGB components. So I'll create a variable name img RGB, wherein it cv2 dot cbt color. In cbt color, we have the arguments img, the image that we are converting, cv2 dot color underscore bgr to rgb is what the function that converts into rgb components. Yeah, so now we converted the components into its corresponding rgb values. On converting, we need to collect the gestures now. So I'll do that by declaring a variable called results equal to hands dot process of, and in this I'll place the converted image, that is img rgb. Now I'm done declaring the conditions required, whether if an image is available. So now I'll declare an empty list, which I'll tell why we created it in further tutorial. So if results dot multi hand landmarks, that is if there are present more than one hand, or what this does is it gives out the list of all the hands that are detected. So multi hand landmarks. Then in this I'll create a for loop for hand landmark in results dot multi hand landmarks. But yeah, so for hand landmarks and results multi hand landmarks when detected, I'll declare another for id comma lm. Enumerate is a function that Python provides as default. Enumerate of landmark. Now we have done declaring the for conditions, and when this is executed, I'll directly create all the variables at once and I'll explain later. Comma w comma underscore is equal to, so we are converting the shape of the image, that is the pixels, into an integer. So yeah, in the above code, what I've done is we use the first for loop to interact with each and every hand in the results. Then we use the second for loop to get the ID, that is ID number and landmark information for each hand landmark. Then the landmark information will give us h comma w is it will give us the x and y coordinates. The ID number is the number that is assigned to the various points in the hand. Now then we have declared h comma w and an underscore too. This line of code checks the height, width and channels of our image. This will give us the width and height of the image basically. Cx comma cy is equal to are the two variables that I have declared. This what this does is that it finds the central position of our image, and we'll achieve this by multiplying lm.x by the width and assigning the value obtained to cx. Then multiply lm.y by height and assign the value obtained to cy.lm. So then lm stands for landmark, and lm list.append does add all the values of id, cx and cy to lm list. So now we are done with appending all the landmarks that have been created. Let's declare another if lm list is not equal to none. Then we have x1 comma y1 coordinates is equal to lm list of 4 of 1 comma lm list of 4 of 2. So this declares for the thumb finger. The numbers that are specified are the elements of lm list. It should not be null. That's why we check the condition. So we assign variables x1 and y1 the x and y coordinates of the points respectively. That is, I called 4 and 1 for the thumb finger. So they are the x and y of the element in the lm list, which is the tip of thumb. We then repeat the same step for the index finger too. Let's take it x2 comma y2 is equal to lm list of 8 comma 1, there is an 8th element, and comma lm list of 8 comma 2. This is the tip of index finger. Yeah, so now we have declared required ones, and now we need to draw circles at the tip of the thumb and tip of index finger, which are used as the finding points for volume control. Let's do that by cv2 dot circle function. In circle function we have x1 y1, the image that we need, x1 y1 coordinates, the radius of the thumb finger, and also the RGB values. I'll tell that img is the image, comma. Now we need to specify the radius of the circle. Let it be before that we need to declare the x1 y1 coordinates. That is, because x1 y1 is for the thumb, I am starting with thumb, so I gave the x1 and y1 coordinates here. Next I'll give the radius, let it be 13 in this case. Now I'll give the RGB components values, that is red value being 255, and I'll set other to 0. I'll only see a red circle there, comma cv2 dot filled function fills the circle with complete red color now, and I'll do the same for the index finger, circle of image, comma x1, sorry, this is x2 comma y2, and let the radius be same, 13, comma, and the RGB values being same, 255 comma 0 comma 0, and I'll just fill this cv2 dot filled. Now we have created circles at the tips of the index and the thumb fingers. Now we'll repeat the same for index finger. That is, we have to create a line between the thumb finger and the index finger. We do that by using cv2 dot line function. We have line of to the image that we have taken, comma, and in cv2.line we have to consider both the fingers, right? So x1 comma y1, and then x2 comma y2. Now we need to also address the RGB values like any other. 255 comma 0 comma 0, I'll let it be a red line. Now here is the value that we need to mention in the last, that is thickness. Like for circle we have radius, for line we have thickness, let it be 3. Now we created a line between the fingers too. Let's find the distance between points with the hypotenuse function that we have called earlier. That we have to declare a variable, like whatever variable it is, I'll declare it as length, gth length equal to, we have hypotenuse function as hypot of, we calculate, we all know that the second coordinate minus the first one, comma y2 minus y1. So we are done calculating the hypotenuse of the points that we have obtained. Next, let's convert the hand range to the volume, hand range to the volume range. That's how we control the volume, right? So I'll declare a variable wall is equal to numpy, that is np dot interpret, that is interp length is the variable that we are converting, and I'll set the values that convert in the range of 30 and 350. So I'll give it as 30 comma 350. Then I'll give a wall min and wall max. We have declared this wall min and wall max function variables earlier. Now we call the numpy function and np.interp. We converted the hand range into volume range. The arguments that we used here are length is the length that we want to convert, and 30 and 350 are the values where the hand is in front of the camera, that is the hand range. Wall min, wall max functions are the given range that we have described earlier. Now we shall define a volume bar and volume percentage representations by wall bar. We have already declared a variable earlier, we set it to 400 of length being same, comma, and the parameters being same, 30 comma 350. Now I'll set 400 comma 150 as the rest, that is by yeah. So now we have declared the volume bar, and now I want to declare the volume percentage. As percentage is always like just 100, I'll set the range to be 0 to 100, and length is same, and the 30 and 350 values that are the hand range are going to be the same. np dot inter of and let the percentage values be 0 comma 100, as 100 is the highest and 0 is the lowest. Now let's just print the volume, print of wall comma int of length, that is I'm calculating the length in integer type. Yeah, so now we are done with setting the volume and volume bar and volume percentages. Let's set the master volume. That what this does is that we achieve this by passing wall variable. We are setting the master volume level following the hand range, that is whenever the hand is moved, the master volume is going to change. Let's do that by volume dot set master volume level, set master volume level to wall, the variable we have declared earlier, and let's set it to none. Now as we've set the master volume level, we need to create a volume bar in order to represent a volume level. Let's do that by cv2 dot rectangle of the image that we have chosen, image comma 50 comma 150. What this does is that the initial position where we want our volume bar to be present, the rectangle to be present, so 50 comma 150 comma 85 comma 400 is the value that I'm choosing to give. That is the ending position, the coordinates, basically the x and y values. 85 comma 400 comma, now I'll set the RGB values. I'll set the R and G components to be zeros and B component to be 255, and now I'll give how long I want this to be. That is, I want this 4 inches long, so I mean sorry, thick. I want how thick the rectangle must be. Now cv2 dot rectangle of image, that is img 50 comma int of wall bar, that is the volume bar. Now I'll give the x and y coordinates where I want this to be present in the first place, that is 85 comma 400 as the same, and now I'll give the RGB components, that is 0 comma 0 comma 255. Now I want the rectangle to be filled, that is cv2 dot filled. It fills the rectangle with the color that we have chosen. Now we have to put text. I mean, we also want the percentage to be displayed, right? So I'll do that by cv2 dot put text is a function, put text of, let's select the image img f, let's write an f string where int of the volume percentage will be displayed, that is the volume percentage will be displayed in the integer format on top of the bar. Also, let's declare where we want to see this. I'll set this to be 10 comma 10, or let it be 10 comma 40. Now I'll call it as cv2 dot font. I'll want the font to be an italic one, so font italic comma 1. I'll explain what these numbers are later on. These, as we know, these are the RGB components, comma 3. Yeah, so we gave the volume percentage as the first argument, the location we want that to be displayed, the font of the text we want to see it as, the length, that is 1, 0 comma 255 comma 98 the RGB values, and 3 as thickness. So we declared how we want it to be displayed. Now how we display this is cv2 dot imshow of, and imshow, it takes two arguments, the image name, that here being img. This shows the real-time video of the user interacting with the program, that is the user uses the thumb finger and the index finger to control the volume, right? That, and if you want to terminate the program, you can call it as cv2 dot imshow of image comma img. I want these both in same quotes. Yeah. So now if cv2 dot wait key is a function, it waits for no interaction, and if that exceeds the limit where we have set this to, it terminates automatically. Here is equal to order of, and I'll set this to be space so that whenever we click spacebar the program terminates. That's what the order function here does. And if that happens, I'll give it to be, I'll give a break statement there. So yeah, that's the whole program. I saved it on the desktop itself. Let me quickly launch my command prompt and go to the desktop where I saved the folder, and I saved it by the name wall. I'll go to the wall folder. Now, like any other Python file, I'll give Python space and the file name. When I run it, it takes a brief pause and starts the camera. Yeah. So now you can see my hand movement and the volume bar rising and lowering. Now this is just an image, right? Let's check whether it's really working or not with the system settings itself. Now here you can see this is the volume slider bar, right? We generally move this way, but our system is different now. So whenever we do this, you can see the volume slowly rising, and when I completely close my fingers it comes to 0, and when I raise it, it goes until 12 and 13. That's because of what is the range of volume that we have written. So that's how you control your system audio using Python.